67 Malibu, John, back when muscle was muscle. You gotta love the rumble and the power.
Yeah, but this one's overheating a bit. No worries, today on Tech Garage, we're gonna upgrade this coolant system and we're gonna take you through an entire system so you'll be confident to tackle any problem.
Tell you what, we're close to the shop now. Why don't we pull it in?
Let's bring it in. Welcome to Tech Garage presented by Advanced Auto Parts. Today it's all about the cooling system. We're going to take you from the water pump through the radiator, and we're going to even address a heater core. Now, more importantly, we're going to get you back to the garage because under the 67 Chevelle, we got a couple problems we're going to address. First off, the water pump, it's leaking. We'll go ahead and put a new one on. And then second, the car's overheating. So we're going to put a Flex-a-lite radiator and fan system on here that's going to be able to handle any of the heat. We build horsepower, we're going to have to build some horsepower into the coolant system.
You want to see why this matters, specifically why this matters so much? Not only is cooling system failure the #1 cause of roadside breakdown in the country, it causes a lot of heartache. Now, we're going to show you something you've probably never seen before on the project car. Chase, go ahead and fire it up. All right, I hope you won't put a glass tube in place of your upper radiator hose. It's not going to hold up very long, but we did that deliberately to show you, to paint a picture of corrosion. Chase, our chief technician, put new antifreeze in this engine just 3 days ago. John, it's only been through 2 heat cycles. And look at the corrosion, the oxidation, the rust, the contamination. There's just no way this cooling system in its present state can be effective and do its job for all the power we're about to create.
No, it's not going to do its job. And you know, he also left the thermostat out to show you the flow. And some people do that. They actually take the thermostat out, Brian, thinking it's going to cool better. That's really not the case. What's happening is the water's flowing so fast, as you've seen, it's not having time to actually transfer the heat in the radiator. That thermal transformation that has to happen.
Not happening.
No, but you know what? We'll go over to our cool toys and take a look at some of that theory now. Now, it's all about that heat transfer. The law of thermodynamics. Well, what does that mean? Simply just transferring heat to an area that has heat to an area that has less heat. Now on my bike, it's air-cooled. Cars are usually liquid-cooled. We can see it right here. This air-cooled system has fins on it. So what's happening is the combustion chamber's firing, I'm transferring the heat. Well, if you ever rode a bike, you know these fins get red hot. So what's happening is the air's coming across, this is hot, the air has less heat, it's jumping off of here, and it's going into the outside air. Now, on a car, a little different story. Our car has liquid cooling systems and uses antifreeze. And you can see my demo right here. The piston's going to go up and down. It's going to cause heat on this cylinder. Well, it rides in a jacket of coolant on the outside. Then it transfers from the hot cylinder to the coolant. It's going to take a ride all the way to the radiator where we're going to throw it off. Here it is in action on my trainer. You can see right here, the piston's on its way down. Well, when the piston goes down, we're going to suck in that air-fuel charge. When we do that, it comes up. Bam, that piston's going to fire, that spark plug fires, that combustion gets really, really hot. So all this time it's burning, it's going down. I'm getting about 1700 degrees Fahrenheit on these cylinder walls. Well, law of thermodynamics. Once again, it's transferring from the cylinder walls over here to this coolant jacket. That's where your coolant's riding, right next to the cylinders here. Then it takes a ride all the way up to the radiator, where the radiator is going to dissipate the heat once again. Why? Well, my outside air, my fan's pushing, causing convection. It's going to go through there. The heat's going to jump off of the radiator to the outside air. Our coolant's going in at about 200 degrees, and our outside air is coming around 80 degrees. Bam, it's jumping off. So in essence, I'm taking the heat out of the engine, giving it a ride to the coolant system, and throwing it to the outside air. Air conditioners take the heat out of the cab to the condenser in the front of the car and throw it to the outside air. Now on the opposite side, if you want heat inside your car, we also use the law of thermodynamics. What we do is we take that hot coolant, we run it through a heater core. I have a heater core right here, and you can see this one's actually leaking, so we had to replace it. This is located inside the car, up under the dash. The coolant's going to ride through here. Now remember, that coolant's 200 degrees, 220 degrees. Inside the car, it may be 30, 40, 50 degrees. heat's going to jump. Heat's going to jump where? Well, this time it's going to jump off the heater core inside the car, and you're going to feel hot. So with those basics down, we should be fine. Now we need to get over to the Chevelle, and we'll do that right when we come back with more Tech Garage presented by Advance Auto Parts.
Which of the following has the best cooling ability? A. Water, B. Copper, C. Ethylene glycol coolant, or D. Steel? The correct answer is A. Pure water has 1.4 times the heat-carrying ability of pure ethylene glycol, but pure water forms rust on engine parts, thus must be used with ethylene glycol and other additives in coolant. This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by MagnaFlow. We've got the power and sound you're looking for. Stage 8, the world's best locking fastener. Steele Rubber, quality crafted rubber parts and weather stripping. And by Advance Auto Parts. Let's get you back to the garage.
Welcome back to Tech Garage, presented by Advance Auto Parts. We're coming along nicely here. We have the old fan removed. That's a beast. We've got the old shroud removed. We're not going to need to reuse either one of those. Also have the belts off, and even a couple of the water pump bolts are out. That's been in a long, long time. We've drained the coolant out of the system and captured it appropriately so that we can dispose of it safely and appropriately. And now we're ready to work on this water pump. We've got the pulley nuts loose. Work that pulley right off the front. Now in our case, we're going to reuse this pulley, so we're going to take good care of that. In your project, you may also need to reuse the stub for the heater hose. We do. So I've been pretty ginger with this and backing it out. Got it finger tight. We're going to clean this up and make it really nice so it's a professional install on the new water pump. Check and make sure what you've got to save in this project. I got 2 water pump bolts out. They were a little bit of a battle. It's been on married to this engine for a long, long time. So you may need to give this pump just a little bit of encouragement coming off, but we're getting there. I got this guy sitting in the background as my motivation. This is going to be an awesome cooling system once we're done with the upgrades. Okay, the water pump is actually pretty loose, and I think with a little bit of encouragement, I can get it off. That thing's been through a battle. There's my pan underneath, just in case. It's been through a battle. If you want to see how these things really work, I think John's got the answer.
Let's talk water pumps. I have a whole bunch of them right here on the table. Now, what is a water pump? Well, it's the heart of the circulation system. It's actually going to pump the antifreeze through, coolant. You can see it right here. My actual impeller spinning. As the impeller's spinning, it's going to take that coolant and circulate it through the block like I showed you earlier to transfer that heat. A couple of bearings in here to support the shaft. This is belt driven, so we're going to have the belt driving the front portion of this, and it's actually going to pump the coolant through. And a few seals through here that you want to check. Simple checks, just check the bearing, make sure it's not wobbling around, listen for any noise, and if you pressure test your car, your water pump could be leaking like ours was. Front wheel drives, transverse engines, you may have seen this before. Impeller on the back, same design. Shaft in the front, 2 little bearings, just a different look. Now, what we get at Tech Garage all the time is, give me a water pump for a small block Chevrolet. They're all the same. Well, that's where the similarities end. These two look alike, but inside, big difference. It's got the different bearing design right here. You can see the housing's real fat and this one's small. This one's going to support a lot more weight. It's going to also support that horsepower that we're building into our Chevrolet. Well, why do we want to do that? Well, you may put a Flex-a-lite fan on here. You may be running all kinds of horsepower that's pulling this. Also, the impeller design and a few other things. So when you're making your water pump choice, if you're going to beef up your engine or you're going to change your fan design, it's always a good idea to go with a heavy-duty water pump. Nothing wrong with this one for a regular design, but we're going to beef ours up a little bit. Now, if you have a timing belt driven water pump, we got some issues because this thing might leak some coolant. And let me tell you, coolant and timing belts, they don't get along. What could happen is I actually leak on here. And if I leak on here, there's a good chance that this belt's going to stretch and it's actually going to jump. And if you jump a tooth or 2 or 3 teeth, What happens with interference engines, the valve then collapses, hits the piston, and that's catastrophic damage. That's a huge, huge repair. So it's real easy. You're down there and you're doing this big old job. Why not just get a whole set? Dayco makes a set here. You can see that comes with the water pump, timing belt, bearing, tensioner, and everything you need to do the job right. It's a pretty good look at water pumps, but I think we better get back to Brian. He's wrapping up our Chevelle.
Okay, we're one step closer. We've got the new water pump hanging off the front of the engine here. I'm keeping this loose so you can see the surfaces between the new water pump, the gasket, and ultimately the face of the engine. We spent a little time with the die grinder, just an abrasive cookie on here to get those surfaces clean. The tiniest little bit of RTV or prior gasket will absolutely cause a leak. So we spent our time, we got it cleaned up. If you have any debris that gets down in the engine and the cooling passages, get the shop vac out, get it out of there. You can't have any debris floating through the system. So we're going to have a great marriage here between the water pump, use the gasket that came with it, no RTV here, use the gasket that came with it. Water pump mounts right up, and we've got thread sealant on all of the new mounting bolts. You've got to use this thread sealant because ultimately coolant will wick up these threads and create a leak. We've already had one of those on the old water pump, we don't want any more. All the other studs have it. We're going to go ahead and use a power ratchet to get these set, but ultimately you're going to need to torque these to spec. And bring this in just like I do lug nuts on a wheel. To pull it up nice and uniform, going easy, got good contact. Gaskets are all still good. Top right. That is a great looking new water pump. 30-pound torque spec here. You got to do this. There's one. Two. I'm going to come back and hit them one more time when we're done before we button this up. Now, we've earned the right to move up to the thermostat here. Keep a rag in the top of the engine. You don't want any debris getting down in that cooling passage. We've got this all cleaned up as well using the die grinder and the abrasive pad. That surface is completely flat. Again, lots of age, lots of corrosion, contamination was on here. We got that all removed so we can get a great mating surface for the gasket. Stant fail-safe thermostat. What does that mean? Well, if this thermostat were to fail, it would fail in the open position. So you aren't going to have any overheating issues with high pressure when you don't want it, right? It never happens at the right time. Sets down in, again, that ridge is clean, flat surface on the bottom. And if you're thinking about RTV, don't do it. Now, a lot of you noticed that the neck we had on here previously was the wrong neck. You're right. We had that for the glass tube demo, but we're actually going to reinstall the proper neck for this engine. Goes down one way, make sure your holes are clear. We don't need thread sealant here because it doesn't go down into the cooling passage. But on some applications, you'll need thread sealant on these mounting bolts as well. I've got these snug, I'll torque them, and finally, the heater hose adapter stub. This absolutely needs a little thread sealant on it. We don't want this leaking. We're going to do a professional job here. Do it right, do it one time. Gingerly put it in, not cross-threading anything here. I'm taking my time. I'll tighten this, I'll torque the neck, and we're ready for that Flex-a-lite.
Welcome back to Tech Garage. Now, Brian brought us a present. He's got the radiator out of the old Chevelle, and we got it right here. I'm just in the process of ripping it in half with this reciprocating saw so I can show you the inside. Now that did the trick. You can see the inside's all starting to deteriorate. Some of the fins were messed up. Now here's the deal. There's two types of radiators. There's a top draft and a side draft. The older cars, they may have a copper tank like this on the top. The fluid goes here and it goes actually down. It's called a downdraft radiator. It goes down and it cools that way. Now our newer car, a little bit different. This is all copper. This one here is aluminum and these tanks are plastic. This is called a side draft radiator because it goes this way. It goes from the right to the left and the tanks are on the side. Now another important part I want to show you that's in this radiator are these cooler lines right here. Now these cooler lines, if you have a car with an automatic transmission, or perhaps you just have an oil cooler, it's going to flow through here, and then you remember that law of thermodynamics? The coolant's flowing through at about 200 degrees. The automatic transmission fluid or oil, because of the torque converter getting it really, really hot, is going to go through a lot hotter. So the heat's going to transfer for this tubes into the coolant, then through the radiator and keep it cool. So if you open up your radiator cap and you see a little pink, it may be automatic transmission fluid or a little bit of oil. If you have an oil cooler, it's probably this one leaking right here. That's a pretty good look at some basic radiators, but we need to get over with Brian and help him put that big Flex-a-lite in that Chevelle.
I sure could use your help, buddy. I appreciate it. Tell you what, John, I think we're in good shape. We got the belts reinstalled, good tension on the alternator belt, good tension on the power steering pump and power steering belt. We're in good shape. The Flex-a-lite brackets were incredibly easy to install. We just drilled 4 new holes to get good meat, good steel there on the mounting, and we're ready to install this Flex-a-lite beast.
Yeah, and this is a really nice package. You know, we took it right out of the box with the fan attached and everything. I mean, it doesn't get any better than that. And also, you know, we gained a bunch of horsepower. Well, how do we do that? Think about it. We had that big silicone viscous driven fan on the front of that car. We had to turn those blades, turn that fan. That took a lot of horsepower. We're going to gain it using this electric fan.
Flex-a-lite makes this incredibly easy. The fan was already installed, and they sent another critically important tool. I've been guilty of this. I've been the guy that didn't use the cardboard on the reinstall, and I'm going to tell you what. To protect your investment, especially one like this is huge. It's a meaningful tool. It's a small step, but it means a lot. We bend this out and get it set in, and it really is less about protecting the back of this condenser, because it's not even being used, and more about protecting the front of the new radiator.
Absolutely. Let's drop this beast in there.
All right.
All right,
Use
you
the
go
number
ahead.
2 track.
Go ahead and get yours lined up, and I'll follow.
I'm in.
You're in. All right, let me get my bracket lined up. There we go. Just kind of
Right
come down easy, gradually. Got a couple on the bottom. Just kind of get them lined up.
Yep.
There we go.
Bottom's good down here.
All right, all the way down. Great.
Yep.
Let's see what we got.
Got some wrenches to snug that. I can live with level. How about you?
That's perfect. Unbelievable. All right, we'll take this and snug this up a little bit. Both sides. Now, all that's left is we got to go ahead and put the radiator hoses on, fill this thing with coolant. We're ready to run it. All right, when we come back, we're going to show you how to wire up this fan and give you some good wiring practice. We're also going to take the email question of the week, so stick around. We'll be right back.
This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by Dustless Blasting. It's the future of surface preparation. AP Laser, leading the way. Flex-a-lite, still making it in the USA. And by Advance Auto Parts. Let's get you back to the garage.
Now, welcome back to Tech Garage, presented by Advance Auto Parts. Well, maybe you wanted to put an electric coolant fan on your car, but you're intimidated by the electrical system. No worries, I'm going to walk you through it step by step. Now, our Flex-a-lite system, I got it right up here on the board, and it's quite simple. We just got to understand a little bit about basic electricity and how to read a schematic. Now, they sent a control module. Now, a control module is nothing more than a fancy relay, and you can see it's labeled with all the terminals. You got the B, which is the battery. That's the hot wire. You got to make sure that's fused. You can see the fuse right here, and they put a 40-amp fuse in it, so we're protected. Then the C is a control wire. The C actually goes to air conditioning. If you had air conditioning, you actually want this guy to kick that fan on anytime you turn the air on, so you pull air through the condenser. Over here is our M. That's a manual switch. We actually opted to get that. That goes inside the cab of the car. The driver can turn on that manual switch. This guy likes to take it to the parade. It's going slow. It's getting hot. Go ahead and turn it on. If the thermostat don't catch it before it, this will override it. Nice option. Come over to G is the ground, battery ground, once again a thick wire, and then we have a little battery plus for ignition. My ignition doesn't have to be so big because a relay controls high amps by low amps. So when I turn on a low amp circuit, I control the high amps, which our fan is drawing. Last but not least are our motor terminals, negative and positive down at the motor. Come over to the bench here. We already got our wires pre-wired up. I like to use good wiring practices, shrink wrap, make sure there's no corrosion. I use the crimpers and the cutters, the proper tools, make sure everything's in good shape. Now what I'm going to do is I'm going to take the module down. We're going to go ahead and assemble it. put it inside the car. So if I take the wire down, Brian, I'll give you these wires to start working on the battery.
Great.
Take my box down here, start out with the bottom one here, get it started. That's perfect. Come over to the top, get it in. We pre-drilled some holes there so the self-tapping screws will go right in. We'll come back later and secure everything. Now I got my probe. I want to actually take it and stick it into the radiator here and go clean through the radiator. So that'll actually sense the temperature right there. And then all we need to do is take the wires over here.
Power lead. There's your ground. We'll reroute these and dress them up here in a little bit.
Thanks, Brian. We'll go ahead and hook this up. That's about all that's left.
We're getting there, John. Now all we have left is the email question of the week. John, we got an email here from Harley in Galveston, Texas. He's got an 07 Malibu that he recently took to the shop, and they replaced both warped heads. They also said he needed a heater core, and Harley's wondering if both problems could have happened at the same time.
Brian, sounds to me Harley's feeling a little cheated. And Harley, that's probably not the case. When it comes to coolant systems, there's a cause and effect. Your heater core was leaking. We saw one earlier. Once that heater core starts leaking, your coolant and antifreeze level starts dropping and dropping and dropping, and eventually you might have overheated the car, which caused the warped head.
You know, today's heads have a lot of aluminum and magnesium and other alloys in them, and it's no longer enough to run the old cooling system at average, right? It's got to perform uniformly, it's got to cool everything uniformly, so you don't get a spot overheated and get a warped head.
That's right, and that's why it's so important. Anytime you get a car hot, replace the thermostat. Just put a new one in regardless. And the condition of the coolant's just as important. Brian, I got some test strips I'd like to dunk in there.
That's perfect. Now, obviously, new antifreeze, old antifreeze, I think that was out of the Chevelle project. What are we testing for?
Well, two things, pH and glycol level. And if I dunk them in there, you let them sit for about 30 seconds, and then you come compare them to the bottle right here. What you want is you want a high pH level and a high glycol level so you don't get a lower boiling point and you don't lose that thermal efficiency.
Great test, and something we've all got to understand is the quality of our coolant that we have in our systems. Now, I thought the Chevelle project went great today. I'm excited that we touched that entire cooling system. We made a lot of upgrades along the way. That thing's not going to overheat anytime soon.
That's for sure. That water pump's going to flow a ton. I had a ball doing it. Well, we're out of time for today, so we look forward to seeing you next week. From our garage to your garage. Thanks for watching Tech Garage.
Production assistance for Tech Garage is provided by Chipola College, located in Marianna, Florida. Founded in 1947, Chipola College has a current enrollment of over 2,000 students. Chipola was recently ranked as one of the top 3 community colleges in the United States.